Okay, next concept is potential energy of a dipole, electric dipole in an external electric field. It is one of the important concept from the point of your examination. Okay, it will be asked for 3 months. It is asked for 3 months. Important concept. Be attentive here. So potential energy of electric dipole in the presence of an external electric field. So already this diagram we have studied in previous classes. That is, in the first chapter, the torque acting on an electric dipole. If you remember, we have considered an electric dipole kept in an uniform electric field. There, at the charges, two equal and opposite forces were acting. Those forces or the couple is the responsible for the rotation of that electric dipole, and that forces or the couples are called as torque, right? Okay. So here also we have the diagram, the same concept. So this is a uniform electric field. Uniform means throughout the region the field will be constant. Electric field will be constant. In that electric field we have kept an electric dipole. Electric dipole means two equal and opposite charges. So ಈ ತರ ನಾನು electric dipole ಅನ್ನು ಇಟ್ಟೆ ಅಂತಂದ್ರೆ at both the charges. So ಈ ತರ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಡಿ, exactly horizontal consider ಮಾಡಿದ್ರೆ ಅಂತಂದ್ರೆ on both the charges we have force. So on positive charge plus q charge we have a force in this direction, and at the negative q we have the force in this direction. Okay, e direction naga force iruttada. So then what happens, that forces, two equal and opposite forces, we are going to rotate this electric dipole. Okay, then that couple of force is called as torque. Is it clear? Okay. So then what happens? It will rotate through a small angular displacement theta. So here theta means the angle between the direction of electric dipole movement and the direction of electric field. The direction of electric dipole movement means it is from minus to plus charge. You can look here. This arrow mark indicates the direction of electric dipole movement. Consider an electric dipole having dipole movement p. Okay, consider an electric dipole having dipole moment P placed in an external electric field E, placed in an external electric field E. Then the torque acting on the dipole is given by tau is equal to, already we have studied it in previous classes. Tau is equal to Pe sin theta, right? It is the torque, means the force which will rotate the electric dipole. Now we will calculate the small work done for So ಹಿಂಗಿದ್ದು horizontal ಇದ್ದು a little bit rotate ಆಗ ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಬೇಕು ನಾವು means the work done by the torque means the work done by the external electric field. So now the small work done by the torque on dipole. The small work done by the torque on dipole for a small rotation through d theta is right. So dw is equal to, in normal case the work done will be equal to force into displacement. Okay, in a linear motion case the work done is equal to force into displacement, but here we have the angular displacement. It is rotating in an electric field. So here the force which is responsible for the angular displacement is called as torque. So torque into the angular displacement d theta, force into displacement, torque into angular displacement. Now substitute the value of torque from this equation. dw is equal to E sin theta into d theta. Now we need to calculate the work done for the total angular displacement. We don't know from where to where it has been displaced. So for that total displacement, first we have considered the small displacement. So all this small displacement, where we have this d theta, from all this small displacement we are going to get the total displacement. The sum of small displacement is equal to the total displacement. So now the sum of the small work done will be equal to the total work done. Now I'll consider the work done from foreign dipole in rotating it from theta 1 to theta 2. Here theta 1 I'll consider pi 90 degree, like this 90 degree. From 90 degree we are bringing it to 0 degree, or else something else theta. From 90 degree to theta degree. Okay. Now total work done on dipole. The total work done on dipole from the angle theta 1 is equal to pi by 2 to theta 2 is equal to theta. So we need to add all the small displacements dw's. So then we have to integrate over the limits pi by 2 to theta. So that is w is equal to integration from pi by 2 to theta dw, which is equal to integration from pi by 2 to theta. What is the theta value? We have here. So d sin theta d theta. So p, e are the constant. Take them outside from the integration. So that implies w is equal to p e. Now integration from pi by 2 to theta sin theta into theta. What is the integration of sin theta? that is minus cos theta. So which is equal to P into E minus cos theta from the limits pi by 2 to theta. Take this minus outside. So that is nice. W is equal to minus PE cos theta. Wherever we find theta, first we will apply the upper limit minus cos of lower limit. So that is cos of theta in the place theta upper limit. Cos theta minus cos of lower limit, that is pi by 2. What is the value of cos pi by 2? It is cos 90. So that is 0. So then this is equal to W is equal to minus PE cos theta. Okay, this work done will be acts as a potential energy of a dipole, right? So here this work done is equal to potential energy of a dipole. Potential energy of a dipole, right? It is important one. It will be asked for 3 marks.